Hello class, let's take a look at example 4. Now this is what we're encountering in example 4. So you're still estimating the parameter of in this case the mean, but we have some major change that we haven't actually talked about yet. And this is the idea that sigma's not known. Now, when sigma's not known, what actually happens is that the actual distribution that we're going to be looking at, it's going to be one of these. So it's still bell shape, but it's a slightly different type of bell shape. Now, this distribution is based on degrees of freedom. And the actual degrees of freedom that we're going to be looking at the t distribution, it's going to be depending on the number of n. So df is equal to n minus 1. Now, let's actually take a look at the problem since it's very similar to the previous scenario. If you have the value of c is equal to 0.90, then the values of alpha is equal to 0.10. And then alpha divided by 2 is equal to 0.05. Now, as we partition the distribution, you're now going to have that this is actually a t1 and this is going to be a t2. And this is because when we have a distribution and the values of sigma is not known, then in that case, your distribution happens to be bell shape, but it's a specific type of bell shape. It's just called the t distribution. Now, you're still going to have the following values to be the same. So you're still going to have that c is equal to 0.90. In this case, this area here, and let me actually shade it, which is the tail. It's going to be 0.05, which is equal to alpha divided by 2. The other tail, it's also equal to 0.05, which is equal to alpha divided by 2. Now, your degrees of freedom, and let me write them on the side, are equal to n minus 1, or the closest value on the table. Now, we're told that the actual sample, in this case, it happens to be a total of 20. So for this particular problem, we're looking at a degree of freedom of, well, 20 minus 1, which is equal to 19. Now, let me show you how to find this actual value, but you're going to be looking at a tail that has technically 0.5 in one of the tails with a degree of freedom of 19. So you're going to be looking at the following table, and I just cut and pasted a portion of it. In this actual table, we're looking at degrees of freedom of 19, which is actually here. The area in one tail, we said it was 0.05. So the actual critical value is going to be at the intersection of 19 degrees of freedom and then technically 0.05. So in this case, I'm looking at 1.729. Let me double check. This is 1.729 at the intersection of 19 and 0.05. So this, it's going to be 1.729. And this is approximately, as well, negative 1.729. And let me confirm the value again. It's at 19 degrees of freedom, and then area in one tail, it's 0.05. So our main answer is that the critical value, I'm just going to call it ZV, it's approximately 1.729. Which happens to be our final answer. Now, let's take a look at example 5 in the last example for this scenario. You're still going to have that, well, in this case, they're estimating the parameter of a mean and sigma's not known. So we're going to be dealing again with a scenario where we happen to have the t distribution being the actual shape. Now, let me actually get the following values. So the values of alpha is equal to 0.05. Alpha divided by 2 is 0.025. Degrees of freedom are going to be equal to the values of 30, or the closest values on 30. And then don't forget the actual arrows. This is going to be our T1. That's going to be our T2. This value of C is equal to 0.95. And we're going to be looking at, well, 30 degrees of freedom and area and one tail. Let me just shade the tails to be 0.025. So this is 0.025, which is equal to alpha divided by 2. This is 0.025, which is equal to alpha divided by 2. So we're looking at 30 degrees of freedom and 0.025 to be in one tail. So 30 degrees of freedom, it's actually going to be here. 0.025, it's actually right next to it. So you're looking at this intersection. Let me erase the previous one so that it's not part of it. So 30 degrees of freedom, and at the intersection of 0.25. So 0.6, I'm looking at 0.683. So your final answer, it's going to be that the critical value, it's approximately 0.683. And let me double check. 30 degrees of freedom, 0.025. Oh, shoot. Give me just a second. It's 0.025. I'm so sorry. It's this one. So our actual value, it's going to be this one, 2.042. So 30 degrees of freedom and 0.025. So 2.042. Now let me double check it. 0.025 and 30 degrees of freedom. 0.025 happens to be here. And 30 degrees of freedom, it's 2.042.